Hi, I'm Male Jeff Jojo, your celebrity mathematician. Let's do a little justice to log reading. We did the introduction last time. Now watch. This one is very simple because I know you can do it. Evaluate log 27 to base 3. Then log 343 to base 1 over 7. Log 1 whole number 9 over 16 to base 1.25. Okay, let me start from here, the simplest one, I. Solution. I. In mathematics, whether you know or you don't know, just write solution so that people know that you are a mercenary. Then write the question. Then ask, oh boy, this is a mathematician. Then your break can be coming down. Now, solution. Given that log 27 to base 3. So in that case, what you do is say let log 27 to base 3 equal to k. It implies that, or you say that is log 3 to the power of 3 base 3 is equal to k. Now I can work directly based on the definition of indices and logarithm relationship that 3 raised to the power of k is equal to 3 raised to the power of 3. Since the base are the same, I will equate the power. Therefore, k is equal to 3. I can now say that log 27 to base 3 is equal to 3 because we said that it's equal to k, so I'll equate it to k, and this is the answer. Good. Now have log 343 to base 1 over 7. Log 343 to base 1 over 7. So if you have this, for you to solve it effectively, you can continue like this, or you can declare this has to evaluate. So I can let it to be something, or I can continue. I can say that this is equal to what? Log 343 what to base 7 raised to the power of minus 1. You know that a raised to the power of minus 1 is the same thing as 1 over a. And 1 over a is the same thing as a raised to the power of minus 1. That's what I did here. 1 over 7 is 7 raised to the power of minus 1. Good. Good. Now, what we'll do is this. You know, in mathematics, you must look closely. Look at this very thing. I have to apply something here that it will look like this. Because I know fully that since 7 is the least number here, and it's a prime number, it can only be divisible by itself. So what I'll do, I will now take 7 and multiply, I'll get this. My mind is all about reasoning. 7 times 7 is 49. 49 times 7 is 343. So, but 7 raised to the power of 3 is not the same thing as 7 raised to the power of minus 1. Now, see what I will do. I can say that this thing is like this. Log 7 raised to the power of 3. Well, log 7 raised to the power of minus 1. At this point, I cannot do something here for now. Let me now see what I can do. So, look at it here. This is the same thing as what? Log 7 raised to the power of minus 1 or to the power of 3, then to 7 raised to the power of minus 1. Now look at it. I can say, okay, this one, for me to balance this, I know what I'm doing. For me to balance this, I will now have to check that this thing, 7 raised to the power of minus 3, cannot give me 343. To give me 1 over 343. So what I'll do is to put minus here. Do we all know that minus times minus is equal to plus? So minus 1 times minus 3 will give me 7 raised to the power of 3. So what since I've added this, I can also, okay, this thing is the same thing as minus 3 log 7 raised to power of minus 1. 7 raised to power of minus 1. Now you can say that log 7 raised to power of minus 1 over to the base 7 raised to power of minus 1 is the same. And we all know that log a to base a is equal to 1. Logarithm to its own base is 1. So log 7 raised to power of minus 1 to base 7 raised to power of minus 1 is 1. So this is like this, minus 3, 1, that is, to the whole of this is 1, which is equal to minus 3 times 1, which is equal to minus 3. Therefore, log 343 to base 7 to 1 over 7, that is base 1 over 7 is equal to minus 3. And for you to confirm whether you are right or not, now you know that we say that this is equal to this according to the definition of logarithm we did to indices. We say that when you have log a base, let's say base b equal to c, that it simply means b raised to power of c is equal to a, right? So from here, that means the base 1 over 7 raised to power of minus 3 is equal to 343. Let's check our answer. Check. Now from that, we see that 1 over 7 raised to power of 3 raised to power of minus 3 is equal to 343. Now what we are checking is that would the left hand side be equal to 343? Now look at it. 7 raised to power of minus 1 raised to power of minus 3 is equal to 343. Now minus 1 times minus 1, because in power law we say that a raised to power of 2 to 3 is the same thing as a raised to power of 2 times 3. So this one will now be 7 raised to power of minus 1 times minus 3 equal to 343. Now minus 1 times minus 3 is 3. Minus times minus is plus. So that means 7 raised to power of 3 is equal to 343. And if you look at this very well, 7 raised to power of 3 is 7 times 7 times 7. Now look at it. Look at it there. So you find out that this thing is like this. 7 times 7 times 7 is equal to 343. And 7 times 7 is 49. 49 times 7 is 343. 343 is equal to 343. QED, quod eram demonstrandum, proved. That means the left hand side is equal to the right hand side. That is how to prove whether you got it right. So this answer is correct, and you see how we did it. So you must reason in mathematics very well. Now we're given log 1 whole number 9 over 16 1.25. This is the logarithm we're given, and that's okay. Let's log 1 whole number 9 over 16 to base 1.25 equal to b. That means it simply means that 1 whole number 9 over 16 is equal to 1.25 raised to the power of b. Now, if you have it like that, 1 times 16 is 16. 16 plus 9 is 25. That is 25 over 16 is equal to 125 over 100. All raised to the power of what? B. Now, look at it. 25 can enter 100. 25 can enter 125. 125 over 25 is 5. And 100 over 25 is 4. Now look at it. That means 25 over 16 is equal to 5 over 4, all raised to the power of b. Now, this one, if I write it like this, that is 5 squared over 4 squared is equal to 5 over 4, all raised to the power of b. Now look at it. Why I say 5 squared? 5 times 5 is 25. And 4 times 4 is 16. So 5 squared is 25. 4 squared is 16. You get it? You get it? Good. Now look at it very well. In this case, we said that when we have something like this, a over b raised to the power of 2 is the same thing as a squared over b squared. And if it's 3, it will be the same thing as a raised to the power of 3 over b raised to the power of 3. So in this case, we're having 2 here, we're having 2 here. Since the power is the same at the numerator and denominator, I can bracket it and put it as 1 power. Now look at it. This is what I'm saying. Look at it here. That is 5 over 4. 5 over 4 raised to the power of 2 will now be 5 over 4 raised to the power of b. So if you're having it like this, you can agree with me that 5 over 4 is the same thing as 5 over 4. That means they are having the same base, but different power. Since the base are the same, we equate the power. Therefore, b is equal to 2. Because this is the same with this, so we equate the power. Good. So in that case, we can say, okay, therefore, log 1 whole number 9 over 16 to the base 1.25 is equal to 2. And when you check this, the same way I checked the other one, 1.25 raised to the power of 2 is equal to 1 whole number 9 over 16. You get the same answer. So that is that about that. Then part B, they are telling me to do this just to simplify. Yes, I have to simplify. This one is very simple. It's a law of logarithm. This is plus. This is plus. So they will multiply each other and divide by 10. So this one is log 2000 to base 6 plus log 18 to base 6 minus log 1000 to base 6. So what you do here is 2000 multiplied by 18, since they are having the same base. Then this minus, since there's minus here, you divide it by 1000. Okay, this may look somehow to you, but let me quickly do Roman numeral 2. That is part B. Part B. Now what they are saying is this: we're giving log 2000 to be 6 plus log 18 to be 6 minus log 1000 to be 6. Now in this case, if they say you should simplify, what you do in logarithm, we say that log A plus log B is the same thing as log AB. That's A times B. Now we apply the same thing here. This implies that log, or you can say it's equal to, this equal to what? Log 2000 to be 6 multiplied by 18. You must bracket it since you are now multiplying it, because it's a base before. They are now sharing the same base, and since it's plus, you multiplied it, minus log 1000 to base 6. Now this is the same thing as what? What to? Log to base 6 2000 multiplied by 18 over 1000. They're having the same base, so I divided it. Now what to do in mathematics? Since it's just one denominator and it's not plus, we're having 3 0 here, we're having 3 0 up. You don't need to start multiplying until you say 2000 multiplied by 18 divided by 1000. No. Once you see zeros here, there's no plus down. So what you do is to just cancel the zeros. So what I don't need to stress myself. 0 take care of this. This take care of this. This take care of this. So I have 2 times 18. So this is the same thing as what? Log 2 times 18 to base 6. Yes. So that is what it is. And if I do it in that way, I'll have justice to it. So this simply means, if you look at this very well, 2 times 18 is 36. I have log 36 to base 6. That is equal to log 36 to base 6. And you know 36 is 6 times 6. 6 times 6 will give you 36. So look at what we'll do here. This is the same thing as what? Log 6 times 6 to base 6. And this is the same thing as what? Log 6 times 6 is 26. So I now said is 6 what? Squared to base 6. And in law of logarithm, we said that when we have log a raised to the power of 2 is the same thing as 2 log a, maybe to base b or b. So if it's up, but remember, if I have log a to base b squared, that's the base carrying square now. If it's going back, it will be 1 over 2 log a to base b. If the power at the base is going to the back, it changes to 1 over that power. But if it's the log itself, it will remain the same. Please take note. In case you come across that, I did not tell you. Take note, please. That is that about that. Now, if I look at this, that means this thing is the same thing as what? 2 log 6 to base 6. And log 6 to base 6 is having the same value. And we say that logarithm to its own base is 1. So in that case, I can say that 2 into the bracket of 1, because 6 is the same. Log 6 to base 6 is 1, which is equal to what? 2. So this is the answer. Now, they gave me some one here. Do this yourself. Simplify this. Now this part C said, given that log 2 is equal to this 0.3010, log 3 is equal to 0.4771, evaluate log 2000, log 200, and log 8. This is very simple. This is very, very simple. Now, what I'll do is just a simple thing. I'll take this one for me to work for you. Then take log 200 and play with it, okay? That log 200, don't think anything too big. 200 can be 2 times 100 is 200. I know that 100 is 10 squared to its own base. So you don't need to kill yourself, or you take it through another means for you to see what you can do. So now look at this thing here. Given that log this, they say that given that part C, given that Given that log 2 is equal to 0.3010. Some of us are very conversant with this already. And log 3 is equal to 0.4771. They now say evaluate log 200 log 8. So I carry this log 8. For me to evaluate log 8, I want to know that this is the same thing as log 2 raised to the power of 3. We all know that, which is the same thing as 3 log 2. And we all know that log 2 is 0.3010. Same thing as 3, 0.3010. Which is the same thing as what? Now 3 times 0 is 0. 3 times 1 is 3. 3 times 0 is 0. 3 times 3 is 9. 3 times 0 is 0. So this will give me 0.9030. But you can still do it in another way around in case you want your work to be big. If it's theory, or log 8 will be equal to log 2 times 2 times 2, right? Now this is the same thing as what? Log 2 plus log 2 plus log 2, because we said that log A B C is the same thing as log A plus log B plus log C. When you have products, you add them. And if I want to take this, I'll say log A times B times C. So this is what we did here. Now this is the same thing as what? 0.3010 plus 0.3010 plus 0.3010, which is the same thing as what? 0.9030. When you add them, 0 plus 0 plus 0 is 0. 1 plus 1 plus 1 is 3. 0 plus 0 plus 0 is 0. 3 plus 3 is 6. 6 plus 3 is 9. And 0 plus 0 plus 0 is 0. So that is that about that. There's nothing too big about it. So try to play with this and play with this. So thank you so much for joining me online today. Please, the educational system is somehow we need to help it. If we say our children, imagine the score in the JAMB. So please tell your children to subscribe to our YouTube channel and download this video, or follow Mathematics and Technology Skills on Facebook to watch the video. Apart from that, we have done other things like number-based system, indices, and we are now on logarithm. This is not the only thing we do. We also solve other questions, wire questions, and other, good questions that can help them. Then every Sundays from 4 p.m. we have weekly brain test challenge. If you win it, you'll be given prize and you'll be the face of that week. So please try your best. Tell them to subscribe at Matex12. Just search the Celebrity Mathematician on YouTube. The link will be on this video on the write-up. So just click on the link and subscribe to our channel. Get the videos and get them used to it. Mathematics is very, very important. In the technology we're having now, without mathematics, you cannot survive. Just go there, you understand. The prerequisite, you must study mathematics because of how good it is to technology. Modern technology will be unthinkable without mathematics. Thank you so much for joining us. I'm Omale Jeff Jojo, the Celebrity Mathematician. Don't touch the die.